Well, welcome to section 2.3, linear functions and slope-intercept form. We have talked a little bit about slope earlier in this week, and this is the equation to actually find the slope of a line where you have the changes in y over the changes of x. Changes in y over the changes in x. So let's suppose we wanted to find the slope between these 2 points. We would go ahead and take their x and y coordinate for those 2 points and put them into this equation, y2 minus y1 over x2 minus x1. Let's take a look at how that would look in a real question. Let's think of this as x1, y1, and x2, y2. So all we have to do is plug this into the equation. Y2 minus y1 over x2 minus x1. Watch your negatives when you're finding a slope. It's the biggest mistake some people make. Let that not be your mistake. 4 minus 7, and this becomes plus. So you're going to have negative 2 plus 3, also known as 1, and your slope is going to be negative 3. Let's try that again. Well, actually, let's take a look at a picture of what that slope might look like. We want to put this line through negative 3, 7. So let's go to negative 3, 7, and then the other one at negative 2, 4. So I'm going to go to negative 2, 4. And obviously, this line could be extended. And you actually see what that line would look like with the slope of negative 3 that goes through the point negative 3, 7, negative 2, 4. Let's take a look at another one here. Plug this in. We can go ahead and use negative y2 minus y1 over x2 minus x1. That's going to be 0 on top, and that's going to be negative 7 on the bottom. Some people might be thinking, wait a minute, 0, that means it's going to be undefined. But 0 on top is fine. When you have 0 in the denominator, that's when it's undefined. This is going to simplify to a slope of 0. Let's take a look at what a slope of 0 looks like. Let's go ahead and put these coordinates on here, 3, 1. So there is 3, 1. And we're going to put the other one at negative 4, 1. Negative 4, 1. So as you can tell, that's going to give you a flat line. I'll let you guys try the next one on your own in your Cornell notes. By the way, for your Cornell notes, I am sure you've written down this equation. By the way, if you're wondering, it still is equal to m. A lot of you will remember that from Algebra 1. So let's take a look at some positive and negative slopes. I'm going to have my little elf here. It looks like he's on some type of medication. Not sure what it is, but he looks, I don't know, special. So let's take a look here at our little elf friend here. We've got a positive slope. It rises from left to right, almost like reading a book. It rises from left to right. Now, your little handy-dandy elf here is going to really struggle to ski up that positive slope. If you take them over to the negative slope, you can see that he's going to have a little bit easier time on that negative slope going downhill. Sometimes you'll hear in Colorado some of the skiers saying they're going to try and do some negative slope. All that means is that they're skiing. And Colorado's a special place now. It's a little bit off center. Anyways, let's go ahead and take a look at zero slope. We just had an equation like that. Let's get our little handy dandy crazy elf here and get him on that zero slope. It doesn't look like he's going anywhere, anytime fast, does he? So you might want to say that if you have zero slope, you're having zero fun. No fun to ski on something very flat. However, if you were to go ahead and go to an undefined, I'll be honest, this elf is going to die. And remember, you can't spell die without undefined. D-I-E. Sorry, elf. You're going to die on undefined. Oh, there he is. Okay. Let's move on. Function whose graph is a line is a linear function. Great definition for your Cornell notes. You can represent a linear function with a linear equation. Hey, that makes perfect sense. Another good definition for your Cornell notes. And let's talk about a special form of linear equations called slope-intercept form. The slope-intercept form, as you know, is y equals mx plus b, where the m is your slope of the line and the b is your y-intercept. In other words, where the line intercepts the y-axis. That's your y-intercept and then your x-intercept. Oh, look, here are two more definitions for your Cornell notes. Again, here's the slope-intercept form, which makes sense because you've got the slope and the intercept. Slope-intercept. Sheer geniuses who came up with that phrase. Let's go ahead and write a linear equation from some information that they've given us. They said that our slope is 1/5 and our y-intercept is 0, -3. Well, if our y-intercept is 0, -3, then that means it crosses the y-axis at -3. So I can take my form y equals mx plus b and just fill in the blanks. I've got my output area, I've got my slope, I have my input area, and I have my y-intercept. And I have just written a linear equation with the given information. Let's try this one. What is the equation of this line? Our slope is 6, y-intercept is 5, y equals our slope times x plus our y-intercept. Here's our y-intercept at 5. Oh, this is a different problem, so sorry. Let's go ahead and maybe take a look at a graph of this line here. My y-intercept is going to be 5. So I'm going to go onto my y-axis and put my little dot right there. And then I'm going to go down 6 over 1. Down 6 over 1. That's my next point because that's my slope. And I get to draw myself a handy dandy little line through those 2 points. Let's use a different line. This one's going to be a lot better. let's take another look here at writing equations in slope-intercept form. Here we've been given the equation, but they want us to write it in slope-intercept form. In other words, we want to put it in the format of y equals mx plus b. Now, I'm going to torture you a little bit. What does this say? If you said slope-intercept form, you're wrong. It says solve for y. I'll ask you again, what does this say? Nope, it doesn't say solve for y, it says slope-intercept form. Hopefully we'll remember that for tomorrow. So let's take a look at our first example, solve for y. Let's get y by itself. Let's move the 5x over. In other words, we subtracted 5 from both sides, and then divide everything by negative 4. Negative 5 divided by negative 4, and then 16 divided by negative 4. And let's clean this up a little bit. This is going to become negative divided by negative is positive. In other words, simply y equals 5/4 x. And 16 divided by negative 4 is going to be negative 4. This is our slope-intercept form. Yet they asked us for some specific things. They asked us for the slope and the y-intercept. Well, take a look at our equation. Our m value is 5/4. And our slope, excuse me, our y-intercept is negative 4. And that solves our question. In your Cornell notes, I'd like to have try this one, but let's do this one on our own here. What number could we multiply everything to neutralize these fractions? Well, let's find out. Let's first add 3/4 to both sides. And then how do I get rid of 1/2? I multiply it again by the reciprocal, and I'm going to multiply that on both sides, the entire side. This is going to neutralize to 1y, and then we're going to have 2 times 3/4. In other words, 2 times 3 is 6/4. And 2 times negative 1. And simplify this. Cut those in half. 3/2 minus 2. Y-intercept is negative 2. Slope is 3/2. Let's take a look at writing the equation in slope-intercept form. These are ones, again, you have to solve for y. I'll let you do that in your Cornell notes. In other words, solve for y. Now, let's take a look at graphing some of these. Let's use the x and y-intercepts to graph the equation. Well, if you recall, to find the y-intercept, you plug in 0 for x. That's going to become 0, so you're going to be left with y equals 1. So and then if you need to find the y-intercept, you're going to plug in 0, or excuse me, find the x-intercept, you're going to plug in 0 for y. And you're going to be left with negative 2x equals 1. Simplify for x. So we've got a y-intercept of 1 and a y-intercept of negative 1/2. Well, we can plot these 2 points and then graph the line. Y equals 1 and x equals negative 1/2, about right here.